Hi guys, we are going to try something a little different today. I'm using my iPad to record my notes, so bear with me as I do this for the first time. We are in Notes Packet 2. You should have picked that up yesterday when you finished your quiz. So we are, like I said, in Notes Packet 2, and we are going to go ahead and start. Let's see if I can get this to work. We are going to start on page 2, okay? So here we are. Page 2, and we are talking about part 2, which is part of our multi-step equation solving, but we are in what we call special cases, okay? And this is part 2 of lesson 1.3 in your textbook. So up till this point, we have solved equations where we always get one solution, okay? We get an example would be we solve and we get an answer that's x equals 12, right? Well, we have two special cases. We have a case that we're going to come across where we get no solution, okay? And what that's going to look like is that when you're solving, you're going to end up with something that doesn't make sense. For example, 3 equals 5. Please don't ever leave that, okay? When you get something, don't assume it's wrong. You're just not going to leave it. You're going to actually say 3 does not equal 5. You're going to do it that way. And what that means is that there's no solution, okay? In addition to no solution, sometimes you're going to see me use this symbol, which also means no solution, or you might hear me call it a null set. And when you get to LT next year, you're going to hear your teachers, depending on who you get, use the word null set, that term, okay? In addition to no solution, at times you're going to find that you have something called, let's see if I can get this to right, an infinite number of solutions, okay? Infinite number, number of solutions, okay? And when that happens, when you go to solve your multi-step equation, you're going to get something that's a true statement, like 7 equals 7, or 10 equals 10, etc., okay? The whole point is that it's a true statement, okay? And you're going to see me call that, like I said, an infinite number of solutions, okay? Sometimes, because I know you guys always like shortcuts, right? You're going to see me use the symbol. It looks like an R with 2 lines. That means all real numbers. I might write out all real numbers, okay? Or just like when we have no solution, I call it a null set. When you have all real numbers, it's called identity, okay? So that's the terminology you're going to hear me talk about a lot. Okay, let's keep going down now. So what does this all really mean? Let me get to my writing pen. Okay, so here we have 3 minus 4x equals negative 7 minus 4x. Just looks like a standard multi-step equation. I'm going to go ahead and I'm going to add my 4x to both sides. Okay, and when I do that, these cancel. I get 3 equals, and look at that. The right side cancels as well. I get 3 equals negative 7. Now, if you refer to the chart up above, you can see we're going to rewrite that as 3 does not equal negative 7, and that is no solution, okay? No solution. Or you can see my little symbol there as a shortcut, okay? Now, if you want to check yourself, you think, oh, I'm not sure if that's right, what you're going to do is we are going to go over, and I'm just going to write a line here. We're going to go ahead, and we're going to do just like the check we've always done. We're going to pick any number, okay? So you're going to pick any number, okay? I would stay away from 1, stay away from 1, -1, and 0. So pick any other number. So maybe I'm going to pick the number 2, okay? So I'm going to go ahead to my original equation, and I'm going to do 3 minus 4. Oh, look, I came across an x. I'm going to put in my number 2. Okay, so let's do that. Equals, and then we have what? 7 minus 4. Oh, and there's my x again, so I'm going to fill in my 2 because that was the number I was going to test. You're going to see I always put that little question mark up above. We're not solving an equation here. We're just simplifying both sides of my equation to see if they're equal to each other. Okay, so I'm going to go ahead and solve that. That is 3 minus 8 equals negative 7 minus 8. That's going to be negative 5 equals, what is that, negative 15. So you can see that I proved that there is no solution. Okay, and that's how I would do a check on that type of problem. Okay, moving right along, let's flip to page 3. Okay, and we can see problem number 2 here. Okay, and I'm just going to blow this up so we can actually see. And let me get back to my black ink here. Okay, 6a plus 4 equals 4 times the quantity, 3/2 a plus 1. I'm going to go ahead and I'm going to solve this just like I would any other time. You're going through your mental checklist. The first thing you do is the distributive property. And you can see I have that right here. So I'm going to go ahead, I'm going to rewrite it. 6a plus 4 equals, if you need to do that on the side, feel free, 4 times 3/2. Okay. That becomes 6 equals 6a plus 4. Right away, you guys should have a clue. Both sides are equal. We're probably going to have all real numbers, okay? But you have to solve it out. Subtract 6a from both sides. And you're going to get 4 equals 4, okay? And as you recall from the previous chart, that means what? Identity. We could call it identity. We could say all real numbers, or you could also just write infinite number of solutions. Okay, so that's what an example of something that has all real numbers. Okay, let's look at another example here. Number 3, 2x plus 1 equals 2x minus 1. I'm just going to go ahead and I'm going to solve. Okay, I subtract 2x from both sides. And look what happens. Those cancel. I'm left with 1 equals 1. And like I said in the previous slide, we never leave it that way. We actually show that 1 does not, in fact, equal 1. And we can go ahead and use our shortcut now. That means no real solution. Okay? Moving right along. I want you, let's do one more example together. Let's look at 4. We've got a mess of a problem here. We've got everything going on. So the first thing in your mental checklist, you are going to use the distributive property. And it looks like for this problem, sorry, I'm just moving it around here. Looks like we're going to do it on both sides. Okay? So let's change to red. Okay, we're going to use the distributive property and the distributive property. On the left-hand side, we have 6d plus 14. On the right side, now be careful here because we are not distributing 1/2. We are distributing negative 1/2. So negative 1/2 times 12d is negative 6d. And then negative 1/2 times negative 28, a negative times a negative is a positive. We're going to get plus 14, okay? We are going to add 6d to both sides. What do we get here? That's a 12d plus 14. These cancel, we get 14. Now I want you guys to be really, really careful with this number, or this problem. When I subtract 14 from both sides, I'm still left with my 12d on the left. I get 0 here. You had a problem like this the other day when we were practicing in class. You got to follow through. This is multiplication. The inverse is division. So we are actually going to get d equals 0. So this is a case where we actually just have one solution, and it is, in fact, 0. Okay? Don't confuse that with no solution or infinite number of solutions. You can get 0 as an answer. Okay? I'm going to leave number 5 for you. Do on your own. And I will check. Okay? Let's go ahead and I'm just looking here to see what we want to do next. Let's go on to page 4. Okay? And we're going to pick one more to do together. And I want to do number 6. Okay? So we've got this problem up here. I'm going to go ahead and I'm going to distribute again. 1/2 times 6b is 3b. 1/2 times negative 4 is minus 2. Okay, I'm going to subtract my 3b So I always deal with the variable term first. Those both cancel. I'm left with -2 equals -2. And that's true, right? So if we have a true statement, that means all real numbers are a solution. Okay, and the reason I picked this one is that I want to show you how you do a check of this number. So I'm going to tell you my little rule of thumb. Stay away from 1, -1, and 0. Otherwise, take your pick. We can pick any number we want. I'm going to pick, let's pick 2. Okay, pick 2. And because all real numbers are the answer, it shouldn't matter what you pick. Any number you pick is going to make a true statement. Okay, so let's watch what happens. I have 1/2. Let's put some brackets here. We've got 6 times, and I'm going to put my 2 in there. Okay. -4 equals 3. Oh, there's my B again. I'm picking 2. And then we have -2. Okay, let's go ahead and solve this. I'm going to do my parentheses first. 6 times 2 is 12. -4. I'm going to show each step so you guys can see where we're at. Equals. We've got 6 minus 2 here. Remember your order of operations. Now we have 1/2. That gives me 8 equals 4. 1/2 times 8 equals 4. And you can see it works. Okay, so that is a true statement. Going down to the bottom, just as a little recap for you all, we know that no solution is also known as, we can do our little symbol. We can call it a null set. Okay, or we can just say, in fact, no solutions. Okay, then we can have one solution. Let me give you one example. That would be something like 30 equals 100, right? That's where we get our answer, and we know that that is not true, so we say that. Okay, we could get one solution. You could get x equals 14. The bottom line is you get x equals a number, okay? And then coming over to an infinite number of solutions, we can use our symbol for all real numbers, which is an R with 2 lines. You can just say all real numbers, or you can say an infinite number of solutions, or you can call it identity. And depending on what teacher you get next year at LT, or wherever you go, they may use a variety of those different terms, okay? We are in the home stretch. We have one more page to do, and I want to go on to page 5. I know this video is taking me a little longer than usual because I am not used to my iPad yet. Okay. Let's see. Writing equations with no solution, one solution, and infinite solutions. Okay, so now we're working backwards. My recommendation is to always start with an infinite number of solutions. Number of solutions, okay? And I'll show you what I mean in a second. Okay, so you can see in this problem that, or A, B, and C, they're asking us to write some equations, okay? Where when you solve, it says write an equation that uses the distributive property, does not have a coefficient of positive or negative 1 or 0, and has exactly one solution. B asks for no solution. C asks for an infinite number of solutions, okay? I always start with the infinite, okay? I always start here. This is where I start, okay? Now, I hope you noticed that when we were solving these things, these equations, you could tell that when you have an infinite number of solutions, both sides ends up looking the same, okay? So you can pick any numbers. I like to pick some even numbers that are on the bigger side. Remember, don't pick 1 or negative 1 or 0 as a coefficient. So let's start here. Let's go here. Okay, so I'm just going to pick some numbers. We're going to go with 6 times 6x plus 4. Again, there's no rhyme or reason to why I picked this. They just give me, what does this give me? 36x. And this gives me 24 when I distribute, okay? So you want for there to be an infinite number of solutions for the other side to be 36x equals 24. So what I do What are some other factors of 36? You got 6 and 6. What about 12 and 3? 12 times 3 also gives you 36, right? And then 12 times what gives me 24? 2. And look at that. I now have two sides of an equation that are the same that are going to give me all real numbers as a solution. Go ahead and follow through and solve this. Minus 36x minus 36x. Oopsie. Would help if I could write. 24 equals 24. And you just wrote an equation that has all real numbers as a solution. Okay? Now, after I do that, I'm going to go up a little ways. Let's just get my pen here. I next do the one that has no solution, okay? So I kind of work backwards. This is oopsie. We'll call this step 1, and I'll call this step 2. Okay, that's where I go next. Now, the good news is that half of the equation is already done because this is what I do. Okay, let's move that up a little bit so you can see. Let's go to green. Okay, write an equation that uses the distributive property, does not have a coefficient of 1, -1, or 0, and has no solution. Okay, look at your left side. It was 6 times 6x plus 4. Okay, I'm just going to copy that over. Okay, you get 36x plus 4. Now I hope you 24. Okay, I hope you recognize that when we were doing no solutions, we were getting something where your variable terms canceled, but then you got two numbers that didn't equal each other. So what I do, I still pick my same numbers, 12 and 3x. That's going to give me 36x. Now, on here, I can pick, let's go bread, I can pick any number that times 12 is not going to equal 24. I just don't want 24 there. So pick any number. Let's pick plus 3. Okay? If I pick plus 3, I get plus 36, right? Minus 36x minus 36x. I get 24 equals 36. That is not a true statement. So no real numbers are the solution. Okay, and the bottom line is when you were doing an infinite number, no solution, this number right here, let's see, this number right here can be any number but 2 because we use 2 down there. Okay, and then, so you're working up backwards. Then when you do your last one, again, I use the same thing. I go back. Okay, I'm going to write the same thing. So I'm going to go 6 times 6x plus 4 equals, and then I just want the other side to be completely different, okay? So just pick some numbers. Let's do 4. The only thing I don't want it to be is 36x. So let's pick 12x. I don't want this to be 36. So let's pick 4 times 8. Watch what happens. 36x plus 24 equals 48x plus 32. Okay, I'm going to subtract 48x from both sides. I'm going to get negative 12x plus 24 equals 32. I will subtract 24 from both sides. I get negative 12x equals 8. Divide by negative 12. I get x equals, what is that? Negative 2/3. And I now have one solution. I know these are tough. We are going to do more of these when you see me tomorrow, okay? But I think that is enough for now. You have a few problems to do, and you are all set for the day. Take care.